So in this video, I'm going to be looking at introducing logs as a concept. So the learning objective here is to be able to understand the connection that exists between logs and exponentials, or I'm just going to keep referring to them as indices. So the success criteria here is that you'll be able to rewrite indices as logs, you can rewrite logs as indices, and you can understand the relationship that exists between logarithms and indices. So let's start by looking at the following example. So I've asked you here to rearrange the following expression, 2 equals 3 to the power of x, and try and get x by itself. Now, if you want to pause the video now, you absolutely can and have a go, but what you will find is that you're actually going to go around in circles. And what you might have figured out is that we need to know the power in order to be able to work out the answer. So for example, if we had 4 equals 2 to the power of x, we know that x in this instance is 2. So what you should start to think about is what happens when we have questions like the first one I presented. It's not as straightforward as the example I just went through, and what we need to do is find a way to work around more complex situations. So when this happens, we use logs or logarithms. So put simply, logs answer the critical question, how many of one number do we multiply to get another? So I'm going to put that down because I think that's really important that you understand. So the critical question here is how many of one number to get another. And that's what logs answer. So I'm just going to write log answers the question. So when you think about that, if we go back to the example where I wrote 4 equals 2 to the power of x, we're asking how many of one number, so that one number being 2, do we multiply to get another, which is 4. So we know that we need to multiply 2 by itself twice in order to get the answer 4. So let's revisit our understanding of indices. So I'm going to write here what we know, which is y equals a to the power of x. And we're just going to do a quick recap on how we label this particular statement. So we know that a is our base. And we know that x, we talk about it being our index. We refer to it as our power. And we even refer to it as an exponent. But now I'm going to call it something else. I'm actually going to call it a log or a logarithm. Log for short. So what this basically means is that we can rewrite an index in a log form. So what that means is that I could write log of y to the base a equals x, and that is basically rewriting the statement that we had above, which was y equals a to the power of x. So putting this into a worked example, let's take a look at what we've got here. So I've said 2 to the power of 5 equals 32. So what we're going to do in this instance is rewrite this in log form. So what we're going to do is start by looking at using the word log. Now I said that basically it is log of y to the base to the base of a, which is equal to x. So let's take a look. So log of 32 to the base 2 equals 5. And if you think about it, it's answering the question, how many of one number do we multiply to get another? So how many of 2 do we multiply in order to get another? So we need to multiply 2 by itself 5 times in order to get an answer of 32. So if we move on, Basically, what I've put here is a summary, so this should help you out in case you are kind of struggling to make a connection. It's okay, this will take a lot of practice, but once you get your head around it and you notice the pattern, it becomes a lot easier to get a hold of. So, if you're wondering how on earth you remember this, think about this. We can write 2 to the power of x is equal to 8, and this can be rewritten as log of 8 to the base of 2, and that's equal to x. So I'm asking, how many of one number do we multiply to get another? So now let's have a look at doing the following examples, or the worked examples that I've got here. So let's start by writing the following in logarithmic form. So I've got here 6 to the power of 2, we know is equal to 36. So let's write that as a log. So I'm going to write log of 36 to the base 6 is equal to 2. And again, continuing this, I'm going to go on to the next example. So log of 1,000 to the base of 10 is equal to 4. And my last one here is going to be log of 225 to the base 5 is equal to x. So now here what I'm asking you to basically do is evaluate the left-hand side, and that'll help us find x. So now let's have a go at doing the opposite. So we've been given our questions in logarithmic form, and we now need to write them in index form. So here what I'm going to do is basically rewrite this. So remember that log of y to the base a is equal to x, and that's the same as saying a to the power of x is equal to y. So here what I'm going to do is I'm going to rewrite this as 4 to the power of 3 is equal to 64. And with question 2 here, again I'm going to write in my exponential form 25 to the power of a half is equal to 5. Now remember, in case you're wondering or in case you've forgotten, I can rewrite 25 to the power of a half as a square root of 25, and we know that that's equal to 5, which is how I got that answer. So hopefully now you're feeling a little bit more comfortable with the concept of a log. And remember, the critical question you have to think about or ask yourself is, how many of one number do we multiply to get another? Because at the end of the day, that's exactly what logs is going to help us identify.